Today we're going to be talking about applications of systems of linear equations, or basically word problems. So the steps for solving basically any word problem is define your variable, or in this case variables, because we're going to have two letters, x and y. Draw a picture if applicable. I don't think any of the problems we've done that we're going to be doing today have a picture, but that's just normally the second step if it's possible. Step 3, write an equation, but actually today we're going to be writing equations, so let's put an S on that. And then solve the equations using your three methods that we have just taught you: graphing, elimination, or substitution. And then you can check your answer. Make sure you answer your question with units. So if it's about money, answer with money. If it's about bananas, write bananas with the number. Our first example says, suppose Terrence has 21 coins totaling $3.45. If he only has dimes and quarters, how many of each type does he have? Step 1 says define the variables. So I'm going to let x equal something and y equal something. I could use D and Q instead of x and y, but a lot of students just kind of prefer having the same letters over and over again, which is fine. But if you don't like those letters, you can always pick any other letters you want. I'm going to stick with x and y today. Now the question said, how many of each type does he have? Each type. What is it? Each type we're talking about? Well, we're talking about the times and the quarters. So let x equal the number of, we'll say, dimes, and y be the number of quarters. Now we need to write two equations. Okay, there's no pictures to be drawn, so we're going to skip that step and go on to write the equations. Now there's two types of equations that we'll be talking about. We have 21 total coins, so we have the total number equation, and then we have another equation that's going to be talking about money. Okay, so let's go back and read again. Suppose Terrence has 21 total coins. Well, if I take the number of dimes that I have, x, plus the number of quarters I have, y, that should give me the 21 coins that I'm talking about. I need to have 21 coins. That's the total number of coins that I have. Now the next piece of information is money. So that's going to go into the second equation. Now $3.45 is a decimal, and I don't really like choosing decimals. So what I'm going to do instead is I'm going to use 345 in terms of cents. Okay? Is there any other cents that we have in this problem? Well, if we keep reading, it says we only has dimes. Now, inherent in the word dime, you need to understand that dimes are worth 10 cents. And inherent in the word quarters, quarters are worth 25 cents. So we have to use the number 10 and the number 25, even though they don't actually appear in the word problem. Dime tells you 10 cents. Quarter tells you 25 cents. So let's say I have X number of dimes. Well, if I have X number of dimes and each dime is worth 10 cents, I'm going to take 10 times X, and that's going to get me the number of the amount of money I have in dimes. For example, let's say you had 3 dimes. You would take 10 times 3 and get 30 cents. Well, what if you had 7 dimes? Well, 10 times 7 is 70 cents. That's why we're multiplying. We're taking the value 10 times the number of dimes we have to get the amount of money we have in dimes. Plus, we also have quarters, don't we? Quarters are worth 25 cents. So I'm going to write that 25 cents times the number of quarters we have. Well, how many quarters do I have? Well, I labeled that y. Y is the number of quarters I have. If I add up all of the cents that I get from the dimes plus all of the cents that I get from the quarters, that should add up to 345 cents. So these are my two equations. Now, if on the test that's as far as you can get, I'm going to get you points for that, okay? Now, step 4 says solve the equation, right? So we're actually going to go ahead and solve. I get to pick how I want to solve this. Do I want to solve this using graphing, substitution, or elimination? Well, I almost automatically eliminate graphing. I don't want to graph anything with a number 345 in it. My graph would be absolutely huge, and I actually don't like graphing that much. So what I'm going to do instead is I'm going to choose either substitution or elimination. Either one is fine. We could substitute by solving for one of the variables x or y of the first equation, or I could eliminate. I think on this particular problem, because the x's are lined up, the y's are lined up, and the numbers are lined up, I think I'm going to choose elimination. Again, you could choose whatever you want. I'm going to choose to eliminate the x variables. I already have a positive 10x, so I want the other equation to have a negative 10x right there. In order to make a 1 into a negative 10, I'm going to multiply it by negative 10. Make sure you do it to the whole equation. I'm going to do that up here. Negative 10 times 1 is negative 10x. Negative 10 times y is negative 10y. Negative 10 times 21 is negative 210. If you need to use a calculator, go ahead and do that. The second equation already has a positive 10 right where I want it. So I'm not going to redo anything with that equation. I'm just going to write it right up underneath it. When I add the 10x and minus 10x, and that goes to 0. 10y minus 25 plus 25, that's positive 15y. And this is 135. And now when I take 135 divided by 15 in order to solve for y, that gets me y is equal to 9. And if you need to use a calculator to do that, that's fine by me. Alright, now I'm going to plug it into one of the two equations. The first equation I think looks easier to me, so I'm going to have x plus y equals 21. But what can I plug in for y? Is 9. So I'm going to subtract 9 from both sides, and that gets me x is equal to 12. So what does this mean? 12 what? That was a long time ago. I'm glad I wrote that down. X is 12, so that means 12 dimes. Y is quarters, so that means y is 9, so that means 9 quarters. So somewhere I'm going to write 12 dimes as my answer and 9 quarters. This is my answer. If I want to check, I can go back and check with the words. Suppose Terrence has 21 total coins. Does 12 plus 9 equal 21? Yep, it does. Totaling $3.45. Well, let's see. If I had 12 dimes, that would be $1.20, right? If I had 9 quarters, that's $2 and then 1 quarter left over, 25 cents. If I add this up, I get $3.45. That's exactly what I wanted. So I didn't go back and check with the equations, because if you wrote your equations wrong, then your check will be wrong. So what I did is I went back and checked with the words and just made sure that the information made sense. And it does.